Aaron, or if anyone watches Comedy Central, Aaron.
Aaron Balake.
Aaron. Is there an Aaron?
How are you doing today, Darren?
It's one of the funniest skits. I'm good. Hey, man, thanks for hanging with us.
Yeah, my pleasure.
I think, one of the things that we've been trying to do in that format is get to the authentic person in this interview. And then if we get enamored by the person, we love the data science work and recommendations. So I think when we just get into data science, it's just like snooze fest. So for me, heck of a path since March, right? I mean, we all been home. We've all been finding a way. But I have to tell you, the people I've been speaking with recently, they're all reflecting, living their best self. They're all, me included, living my best self, not in the best world, but my best self. So going with maybe more of a positive. I want to know how you're living your best self because of this crazy time, but tell me about how you're living it, right? Because I just feel like this week, everyone's like, I've been living the best self.
Yeah, I mean, I think that's certainly true for me, sort of counterintuitively, given, how bad things are in general, that there are a lot of people who've taken positives out of it. Myself included. I was working from home. I just transitioned to working from home right before COVID hit. Most of my team is located in New Jersey. I'm located in Maryland. That was working fine. I was traveling up there every so often. But after everybody, got kind of locked down, my whole data science team, my whole organization moved to working from home, and all of our productivity measures went up. Everybody was happier. Our work-life balance has been better. It seems to be, at least in this field with the folks that I'm working with, to be a really positive change where we're able to have, this balance of, I'll go downstairs and I'll get a cup of coffee, I'll get something to eat, I'll hug my son, and my brain's kind of churning away on a data science problem. And I run upstairs and I, fiddle away on the computer. It's been a much more positive way of integrating work into my life. I think that's one of the biggest changes.
Nice to hear. I can't go back.
Oh, I absolutely can't go back. My quality of life is so much higher being able to do it like this. And you figure, how much of your day would you waste before just traveling and preparing and then, to do the same exact thing, you could do from home in your socks.
It's exactly right. I find that for me, I don't hate Mondays anymore. I don't even know what day of the week it is, to be honest with you. It doesn't matter. But I don't feel like that Sunday night, hey, I have to go to bed early. It's been a great 2 days. Yeah, it's been a great 2 days, Friday to now. Let's start again. And it's not because I've lost my way. It's not like I'm working weekend. It's just that, time is just different. Time is just different.
And it's funny, actually. I've got a big deadline for something I'm working on, and I found myself working on it through the last weekend. But I was working on it not because I was stressed and not because it was like, oh, I've got to get this done. But I was really involved in the problem, and I was on a roll, and I was like, this is cool. I'm figuring things out. I have things kind of working. I want to keep doing it. This is like what I want to do in my free time to figure this out. So it's a very different perspective, I think. Yeah. And, just with my team, I'm a data scientist. I like measures, right? So we use agile methodology for our team, which can be tricky with data science folks because you don't necessarily have defined deliverables you can easily bundle up. But it's worked well for us. And we have these measures across time from prior to people working from home when we were, kind of a general 9-to-5 sort of shop, to now, and our velocity, our agile measures for what we get done are significantly higher. So I can point to, these are the same people that we had. We can look at the different environments and have some concrete measures and say, we're doing better now than we were before.
Yeah. And happier and healthier.
And happier and healthier. Yeah. So our organization made the decision to stay remote. So even, sort of post-COVID.
Yeah, I think, it's, one of the things I think about is just I've had a lot of time to think, right, about a lot of things. When I look back on certain CEOs, I look at Jack Dorsey in a different way, where he was the first to say, I'm going to just make the decision. Let's take all the stress out. We're going to work from home. Yep. Not, we'll check back in 3 months. We'll check back in 6 months, because people probably would have wanted to go to different cities or move back and be with their family, but there was that anxiety of, can I get back? When we can get back? When we call back? And then he just put his lease up right after that. So there's no right or wrong, but I thought that was just thoughtful. hey,
Yeah.
just you be you. Like take one more stress off. Like,
Yeah.
so
It,
I
it
thought that
is
was nice.
it is a little more challenging in my industry, right? So in the federal space, there's a lot of work that we do that requires us to be on site. So we have a lot
Got
of
it.
work that's classified or supporting the intelligence community or various DoD groups. But I have been tremendously impressed with the company's willingness to adjust things and make sure that we're
Yeah.
supporting our customers while keeping people safe. There's been these, bi-weekly briefs. So our CEO, Jennifer Felix, she's ever since she came in was kind of like, here's coronavirus, has done just a fantastic job of keeping the company in the loop on what's going on. This is how we're addressing these problems. Here's
Nice.
the people that have to be on site, but this is what we're doing to keep them safe. I think it's been a great balanced approach and has been received really positively at the company.
So we're going to get into some data, but New Jersey, you missed the diners, you missed the pizza. What do we miss besides the people? Like, are you craving? Is there something in Jersey that you crave? Like food.
So for me, Jersey
Roundabouts. Like, would you miss the
chug
turn and it's
handles.
just like
No. So I'm a Maryland native. So I grew up and I've always lived in Maryland.
and a love of the school, UM, yeah.
Yeah.
University of Maryland,
So Jersey for me, I work with a lot of great people up there. The bulk of my team, some of them are distributed about. The bulk of my team are in Morristown, New Jersey, and then I worked for a number of years with another data science team within ASRC Federal, based out of Wall, New Jersey. But for me, the thing I always crave from Jersey is racing. So I race cars. So I've raced at New Jersey Motorsports Park quite a bit. So that's one of my positive associations for the state is the racetrack.
Well, we got to dig in there for 2 seconds. How big is the track? Is it a mile and a half, 2 miles? And what are we racing?
Yeah, so they have two different tracks there. They have a club racing track and they have a professional track. They call them Lightning and Thunderbolt, respectively, at New Jersey Motorsports Park. And they're road courses. So the longer track is Thunderbolt, which is like 2.2 miles, something like that. Lightning is a little bit shorter. And there's all kinds of racing there. I originally competed in time trials with Mitsubishi Evolution, and then I started racing for Honda in Honda Challenge.
I know a little, a club racer, a little bit. So I'll tell you, for me, dating myself a little bit, there's now a famous helmet painter named Troy Lee Designs. So Troy Lee, for the audience, he paints helmets, Formula One, for NASCAR.
Yeah, I think I've seen some of the work. The name sounds really familiar.
And this was like 100 years ago. And I got into club racing like yourself. I think it was like an under 2 mile track. Wasn't very good, but I wanted to try it, get into it. So I was like, you know what? I'm not going to race every day, but I want to look at the helmet every day, right? So it's the weirdest thing, right? Because it's like, so I said, you know what? I'm going to go get this helmet painted. And I went on Google and this guy came up, Troy Lee Design. I called him. I got him.
Wow.
I mean, it was him in his garage. Like, this was not 100 years ago, but
so he painted your helmet.
He painted my helmet.
That's
cost
awesome.
A lot of money, and then blew up. But I mean, when I found him, I was just looking up creative work of who wants to airbrush. It was like Googling airbrush helmet, right? And
it happened to be that guy. Wow.
Yeah, his portfolio came up like others. I was like, wow, and he nailed it. It was so much fun. And it's still on my desk. It's actually on the other. I'll send it. So now, and for you, is your helmet painted? Is it white? Is it just anything special, or what'd you end up doing on your helmet?
It's all black.
It's so badass.
I definitely had an aesthetic.
So bad.
Yeah, my time trial car had an aesthetic. It was all black with red hellfire and skulls, and so it's a very specific aesthetic.
I listen, you're already better than me. I just went for like the coffee table. Thank you for sharing that. And
my pleasure.
When I get up there, when we do it, we will figure out a track, or maybe we'll even figure out a Formula One race. And I love that stuff. And sadly, we have to get into some data here. So sadly,
that's okay. I love data too.
There was something that I wanted to talk to you about that we don't hear that much about, and it's maybe just the guess I have, but I wanted to dig into synthetic data. I think that is really an interesting little nugget. Can you maybe walk us through what, for some who don't know what it is, Well, what is it?
Sure.
Why does it matter? Like just those basic things that we should be thinking about.
Yeah, absolutely. So, I mean, the general idea is that for any kind of machine learning models that you're generating, especially deep learning techniques, you're so dependent on having tagged, clean data. So, supervised learning just needs it. And that can be time series data, that can be sensor inputs, it can be image stuff for computer vision models. This is so much a factor, though, for the federal government because they don't have the same kinds of avenues for generating this tagged data that, say, a commercial organization does. So if you're Google or you're Facebook, you have people interacting with your tools and systems all the time that are generating data that can be tagged as they're using the tool. And that produces some tremendous data sets for things like natural language processing or computer vision. Facebook's facial recognition, a lot of that comes from people tagging people's faces in their pictures. So they then feed that into their algorithms and are able to develop really, really high performing models. The federal government has endless amounts of data. They have an equal amount to the commercial space, but it's not categorized, it's not cleaned, and it's not tagged. And there are other examples where synthetic data is a huge factor when you're looking for anomalous behavior. So a lot of what the federal government is interested in is things like they're looking for anomaly detection, or they're looking for intrusion events, or they're looking for preventive maintenance, things that are outside the normal operational environment. How do you recognize and characterize those things? So synthetic data can be model-based simulation where you actually create sort of realistic models. It can actually be hardware simulators. So we do a lot of work in aerospace where they have physical, simulator environments of actual spacecraft that are able to perform the same kinds of operations that a spacecraft would perform in orbit, but they're very, very slow. So the cost to run them at greater than, sorry, it's a helicopter going right overhead. It's very, very difficult to run the computations on these things at any kind of speed. Sorry, I guess there's a medevac helicopter landing right next to my house. That's fun.
God. Aaron's calling us from a secret location. If you got to go, let me know.
No, it's okay. I live near a high school, and they will occasionally use the field here as a medevac landing spot. So I think they're landing a medevac chopper next to my house. So I apologize for that. So, two areas we use synthetic data a lot in right now are basically sensor inputs. So this is kind of time series data that's generated to represent both sort of standard behaviors of environments and then an equal amount of behavior that matches these kinds of characterized non-standard events. But we also do a lot of work with 3D synthetic data to train computer vision systems. And there's a few commercial companies that are building up around this technique. Zumo Labs in Silicon Valley is one of them.
Yeah.
But we do this quite extensively for computer vision techniques using tools like Blender and Unreal to create very, very robust 3D synthetic environments and then feed that directly into a machine learning pipeline to train robust models.
Makes sense. I think for me, the punch that landed was how you weaved it to Facebook has this great learning engine. People are tagging people. Synthetic. I love the name. Sorry, I love the name synthetic data. I'm sorry. Like I don't know what else to call it. It's not test data. It's kind of not made up data, but it's a great way to I don't know. I like the name. Sorry.
And it's more,
friendly name.
You can control characteristics in it. One of the things about deep learning models in particular is sometimes it's very hard to tell what the model is paying attention to. So, for example, in computer vision models, what the actual model is looking at to define classification or object detection is sometimes features or characteristics that aren't what you think. With synthetic data, you can actually have this feedback where you look at what the model is observing through saliency maps and other techniques, and then you can actually modify the data to provide a diversity of outputs that balance that out. So if, for example, a very common problem in computer vision is that you'll get these background characteristics that are more impactful in the object detection or the re-identification, where it's actually picking up features from the background as opposed to the character that you're trying to identify. With synthetic data, you can do all kinds of background invariance and distribution of data that you sample from the environments. And you can get significantly higher accuracy results in the real world by just training on synthetic data. So we've seen accuracy jumps of 10 to 20% improvements by using synthetic data.
Amazing. Now, I'm trying to thread a needle here, Aaron. Synthetic data, powerful stuff. We also have, let's call it the data that Facebook is creating on the tagging. When we thread this to ethical and explainable models, like where's the line? Like who's advocating for that line? Like, and I don't know if you can weave these two, but how do we, because this data can be created or generated. Now the output is, where's the line on ethics, trustworthiness? Where do we put the line?
Yeah, I mean, that's a really big question, right? It opens a lot of opportunity for discussion. I think that anybody who's working in data science, who's working in these types of models, has an obligation to consider the ethical considerations of what they're doing. There are several aspects to that. So synthetic data is being looked at as an alternative that is better with regards to privacy. So if you have, data sets that end up with particular representations of people, with a synthetic data set, you can have a broader diversity, and the entities that you're generating are not real, so they have less privacy concerns. There are ways to use synthetic data to help with that level of ethics. But it's also how you use the final product. Even if you train a model entirely based off of synthetic data and it has measurable diversity, and you can measure its impact and its safety in its use case, you have to see how it's being applied. And you can take, machine learning techniques are neither good nor evil. It's all in how they're used. So there are examples that are incredibly authoritarian and very dangerous, and there are examples that are very benign and very useful. And sometimes the line between the two is blurry. There's
sometimes. Okay. I'll take you with sometimes.
Yeah, I think not all the times. I think there are times where
I don't know what it is, right?
Right. And I think, there's also the idea that there's sort of a panacea, there's a simple, safe answer for how these models are handled is just not true. And you run into this a lot in the federal space. My group in particular does a lot of work supporting the intelligence and the DoD and military branches. So you're talking about, AI being deployed in environments where it's in a kinetic environment, there's, weapons involved, those kinds of things. So the characteristics that the model has are going to be carried forward to sort of its ultimate conclusion. You have to make sure that what you're doing is being done in a way that it's not autonomous, that it not only isn't autonomous, but you can't just put somebody inside the loop and say it's intrinsically safe. You have to be cognizant of the fact that human beings are trusting of things that they use to the point that every year people die because they follow the GPS into the sea. This is a known thing that when they have repeated exchanges with systems that they trust, over time, they'll trust them even given bad information or bad choices. So when you make decision aids that are using machine learning technologies, you have to be cognizant of how that's going to be deployed, who's going to be using it, and deploy it in a safe and ethical way. Synthetic data can help with that so that your choices are more diverse and more accurate, but there's also this emerging field in explainable AI, where rather than giving a black box model that's very opaque and you don't know why it's giving you a decision, that you get some insight into, this is the recommendation from the decision aid, this is why this decision aid has weighted these characteristics as important. You have to take the next step to determine whether or not those things, it'll direct your attention to the stuff you need to look at, and then you need to make the final decision.
I am the user who drives into the ocean. I want my data out there so the machines can learn about me and automate my life. And I'm trusting of it. I have a belief structure that there's no such thing as anonymous or confidential. Like, my data is out there, whether I know it or not. I might as well benefit my lifestyle for it. So, but the vocabulary that you're using is the intuition that I think was happening in my brain, right? Of like, somehow Google Maps knows how to get me to where I'm going, right? Like, somehow. And 100 years ago, I used to go to MapQuest, or I have to go to the gas station. Can you tell me how to get onto the New Jersey Turnpike? Or, that's
Absolutely.
now
And
I'll just not even question it. I'll just go and I'm going.
And it's not just the convenience, it's the repeated exchanges. So, there's been a lot of work done in computational sociology and human-centered computing about this, that when people use a technology-mediated system and it gives them the right answer over and over again, their trust grows and ramps up until they don't question it anymore. It's been right the last 10 times, it's going to be right the next 10 times. But then time 11, it does something catastrophically wrong. And if you're using that system to do something that involves life or death, you have a really, really big problem all of a sudden.
Can I go back to synthetic for a second? And
Sure.
Again, I'm not sure if I'm using the right words.
Mm-hmm.
And if we had a full production staff, I'd have my producer pull something up, but I don't have that. And again, might not be using the right words, but the COVID vaccines, was that something about synthetic? I thought I heard something about the model they built. Was there something with synthetic data to help build that? Or I'm not sure if maybe I misheard this word synthetic and drug.
Yeah, so I don't know a whole lot about the process that they used for the mRNA modeling.
I know it was designed. It was a designed.
Absolutely.
Right.
The main companies that were working on the mRNA vaccines were looking at them, like Moderna was focused on cancer research. That was their big focus. So I'm sure they have extensive modeling and simulation that was used.
Got it.
I don't know to what extent, that goes into the process for something like a vaccine, but modeling and simulation is used in almost every scientific outlet in some standpoint.
There's a lot here. So I just want to now spending time with you, just some advice to data scientists or actually data enthusiasts that are graduating, whether it be Maryland or others. If you had to go back, I'm going to give you advice. I mean, what advice? I mean, and I'm going to just kind of throw out, start this trend. I mean, the advice could be choose great bosses or choose big data sets. Choose great bosses, choose very narrow data sets. Go explore the world and don't worry about the data sets. I mean, like this is a whole different place that this group is coming up after us. And it's going to be, I think, like we're talking about, work anywhere. So what advice do you give? Because when I was that age, I was too afraid to move somewhere. So it's almost like my advice might be different than yours, but it'd be like force someone to go out of their comfort zone. What advice would you give this group coming up?
I think one of the big things is, there's always this fluctuation between the AI boom and the AI winter. We're seeing this kind of learning rate right now where deep learning had this huge acceleration, and now everybody joined PhD programs in data science and is like, I want to do deep learning. And now we're seeing some significant roadblocks, things like autonomous vehicles, and you have major autonomous vehicle companies selling off their stock because they found that these technologies maybe have plateaus that were more significant than they expected. And I do actually a good amount of career mentoring as part of my job. And I think for people who are interested in the field, you will do best if you have a passion for solving problems as opposed to the specific tools. So, some number of years ago, maybe it was support vector machines and, or expert systems or, just Bayesian classification. Now deep learning is kind of the big thing. None of them is the end all be all. The exact tool that you use is just whatever the best tool for the job is at the time. Focus on learning the basics, understand the math, get involved in actually solving problems, and find a problem that excites you. And that'll give you something to work on that you don't mind putting the time in.
I'm sorry to cut you off, but you just threw a thought bubble. Like everyone that graduated 100 years ago learning HTML to build web pages, now it's Wix. Now it's WordPress. We're getting to a low code, no code. So I think you're right.
Sure.
So you're learning all of these techniques, but in the next few years, by the time you graduate with this beautiful diploma, it's going to be drag and drop. It's going to be, you want to automate. Like, it's amazing but if you like the problem and if you're creative and you're curious and you just learn everything and just be agile as a person, because this thing is going to iterate on these tools.
I think the tools are always going to change.
And they're only going to get easier. The tools are only going to be gone to a low code, no code.
Maybe.
Most.
I think in the AI ML side, there's always a pressure for things to be commoditized down to a point where it goes from research to kind of a software engineering side where it can be comprehensively monitored, measured, put into a production pipeline. You see that with the sort of ML ops practices today.
Yeah. Yep.
I do think that on the research side, though, there's a lot of heavy lifting to be done there still. There's still people trying unique and interesting network designs and data structures, and we're moving into this data-driven design as opposed to model-driven design, which synthetic data is obviously a big part of that. So I'm a big advocate, and that's kind of why we've gotten heavily involved in the data side. But
listen,
whatever it is, the problem solving is the fun part.
Yeah, I was saying maybe I was making a bit too much of a leap. It's going to go to a no code, but it's getting easier to ship certain things.
Oh yeah, and I mean there are standards now in machine learning in particular that there weren't 5 years ago. 5 years ago, it was crazy. There was no defined libraries, and everybody was doing everything from scratch. There are definitely standards, and you can kind of view that progress as a hill climbing method or a gradient descent kind of thing in either direction, where there are these big leaps that happen where big technology changes occur. And then once they do, there's these local minimas that people explore for a while. And I think that's what's happening right now, where people are, your academic publishing for the machine learning space is like, oh, we did 0.5% better on this particular metric. Not a really big sort of fundamental jump in the space.
Yeah, it's well said.
No, it's a local minima.
No, it's well said. Yeah, I just tried to record that. Can you say that one time? Data to decision. I just want to hear it in your words because you just said it really well. Because they don't understand the decision. The day should be
just
about
the ability to
decision.
take lots of data and make decisions. I think that's the thing that people really struggle with is they see lots of data, they see a bunch of different numbers, and they don't understand the statistics. So they understand how they feel, not necessarily how they can logically make the decisions. And giving them some insight into those numbers would be really helpful.
Do you think it's ML day or do you think it's data day?
I think it's data day. It's got the alliteration, and for a variety of reasons, I think machine learning has some prominence right now because it's unreasonably effective for what it is. But I think there's a more public recognition of the limits of what machine learning as it is today can do. And of course, we had this massive wave of hype, AI. But what machine learning is today isn't that. It's not really AI. And the idea that it's the data and data analysis is the important thing, I think makes a lot of sense.
And that's the top. All right. I'm going to do one this year. It will be this year. It'll be the first one. And we're going to get the virality. And what's cool is in 5 years, when they were saying, how did it start? We'll be like, it was us.
Great. No, I will, I'll definitely, if you get a hashtag or something to post on it, I can post something up about it. I would love to contribute.
I said, I think what you need to do is we need to find a color. Every day has a color. Like it's like we got to just pick. Once we get out a color, I think the rest opens up. All right, cool, Aaron, Aaron. I really appreciate the love, man. This is a cool show.
Absolutely.
I'm second shot vaccinated. We talked about that. I am going to be coming up and love to grab a drink with you if you feel comfortable and everyone feels comfortable.
I get my second shot on Monday.
Yeah, congratulations. Yeah, it's going to be exciting. So thank you for being on the show. We are sponsored by Pandio. We're going to get you back on.
Great. Well, thank you so much for having me. It was a real pleasure.